Hello everyone. Today we're gonna solve the k largest element in an array. So this problem is cool. They give us an array and we need to learn the k largest number. So if we have this array, we're gonna return five because five is the second largest number in the array. And how can we do that? It's very simple if we just use the short algorithm, just a built-in function sort the array uh, decreasingly, and we just need to we need then we return the array. So with this approach, we're gonna have uh, time complexity gonna be O n log n. With n is the first element in the array. So mm, how can we do, how can we do it better? Like for example, how can we reduce the time complexity from O n log n to just O n? So that's when we can think about the quick select approach. This approach is a very similar approach with the quick sort algorithm. So first of all, if we have an array like this, we're gonna have the left and the right, and we're gonna choose an element between left and right, just a random one. For example, if I choose the random one is this one, um, let's say this one. Yep, let's say this one. I'm gonna check whether or not each of the element from left to right, and I'm gonna check if each of the element greater than our random one. So basically, I'm gonna check whether or not this element is greater than 2, and if the element is greater than the random element, we're gonna push all of these elements into our front front line. So it's quite simple. So first of all, we're gonna start with a pointer. Let's say pointer one. Let's start with this one, and we can see that this one is greater than 2, right? So we're gonna swap, gonna just push. Let's say start with the number 4 here for gonna choose one, and this one is not satisfied, so we're gonna move the next one. Order two, we're gonna move next one, and this one is not satisfied this condition as well. Gonna the next one, and this one is not as well, so we next one, and at this point we can see that 5 is greater than 4. So what we're gonna do is we're gonna swap the pointer one and the pointer 2, and we're gonna increase pointer 1 by 1. So which means that this one is 5 and one is 3, and we're gonna increase pointer 1 to place. So basically we're gonna just push all of the largest one front line, and then we're gonna move to the next one in our loop, and we can see that 6 is greater than 4 as well. So we're gonna swap with pointer 1, gonna swap this one and this, and we're gonna have a new element right here is 5 6, and this one is right. And finally we're gonna have 1 5 6 1 3 2 4, and then we already know that we have two two numbers is greater than this number, right? So which means that if we if we consider if we swap this one to this position, or we're gonna have this number at top three largest one, three largest element. So we're gonna search in this from left to the new right, gonna be this position, and we're gonna continue the process until we have exactly the number we choose is the k largest one. That's basically the idea. And now we're gonna implement this one. First of all, let's say we're gonna have to choose a random position, right? Gonna have a random pivot, a pivot, random left to right. To make it easier, I'm gonna write it as a partition function. I have function. Let's put it right here. Gonna choose pivot one. Um, then we're gonna what we're gonna do. Basically, we can just do as the previous example. We're gonna just swap with the right, the most right one, and gonna do the for loop. So we're gonna swap with the right position. Uh, uh, right, but then we're gonna follow from left less than right because we know that right now is random one, and we gonna consider if our uh nums right in the pivot. Let's say that the pivot gonna consider if the pivot is if the nums I is greater than pivot, we're gonna increase left, right, but before that we're gonna swap left and right here, and then we're gonna swap nums left and right, the last one, last operation, and in left, and finally we just return left right here. Perfect. And now what we're gonna do is in the main function we're gonna have a left, right one, left gonna be 0, right gonna go to, and then we're gonna have a while loop, while loop one, and we're gonna here, and then let's say we have a text, go to partition, gonna pass left and right this one, okay, and one we're gonna turn how many how many numbers how many numbers in the top latches one. Now partition one gonna have left, right, right here, and vector pass by pass by and change it. Then if we have the number of in the larger group equal to k, which means that we already find that number. Just gonna need to perhaps we're gonna return the number. Nice. That's basically the idea. And if we have the number of element in larger group is greater than k, that we're gonna have like a minus one. Now f and don't find anything, we just one right here. Yeah. In worst case scenario, our approach gonna have the time complexity equal to O n square. But in average case, we're gonna have O n and O n square in worst case scenario. So so how can we have this worst case scenario? So basically, we're gonna have this case whenever we choose a random one. If we choose a random element equal to the the largest or the smallest number in our array, it's gonna be on. For example, if we choose a random one, is this number, we gonna basically push all of these element in the first place to the front line, right? So 22, 5, 6, 4, and finally one gonna be this one. So this is one time. And the next time we continue to choose the smallest element or the largest element in this one. So it's gonna be the same, and we continue with n minus one time. And each of the time we need to loop through all of the elements, right? So which means that time complexity in this case is O n square. So that's the worst case scenario. And but fortunately we have the random thing right here. We choose the random position instead of just choosing a specific one. For example, if you choose the right position, always choose the right position. We're gonna have problem if our array is increasingly like this. If we always choose this one, the right position, we're gonna have problem with this case. That's why in quick sort algorithm they always choose random one. So because I'm gonna implement the random here left with a random mode with I minus shouldn't choose a specific. Okay, we have graph right and have a oh perfect. We have output here 5. Have output think I have some problem. Graph need to swap left a nice in those. Phew, that's great. And we finally solved this problem. Hope it helped you guys to solve it as well.